When evaluating limits, you always want to start by doing direct substitution. What that means is you're looking at what is x approaching in this limit, and then you're going to put that in to see if the function has a defined value there. And so right here in this first problem, all I'm going to do is put the 1 in, so negative 1 squared plus 1, and I get 0. And move on here to the second problem. The same thing, I always start by doing direct substitution. I want to put the number in to see if the function is defined there. I go put the 3 in for all of the x's. And that's going to give us negative 2. And the third one, the same lines here. Now, I have to make sure I put in a value for the correct variable in this case. It's going to have x's and h's. And this is the limit as h approaches 0. So I'm only going to put in 0 for the 2 h's when I go to perform direct substitution for this limit. And that's just going to leave us with 3x squared. All right, now we're going to look at using some algebraic techniques to evaluate limits. And the more of these that you do, you'll start to see kind of a pattern in how and when to use some of these techniques. Now, regardless of the kind of technique that's going to be required, I still always start by doing direct substitution. And so I look at this first problem here, and I'm looking at the limit as x approaches 1 for this function, and I'm going to go put 1 in. And so I'm just going to put a colon here to show what I get when I do direct substitution. Well, I get 0 in my numerator, and I put 1 in the denominator, and I get 1 minus 3 plus 2 is 0 in the denominator. This is an indeterminate form. So what the indeterminate form means is that I need to do some kind of rewrite with this problem to try to simplify it, and then I would hopefully be able to find the value of this limit. 0 over 0 is typically indicative of there being a hole in whatever the function is that we're looking at. So I'm going to look at this problem, and I'm going to try to factor it. And so I factor it, and I look, and I can see that the numerator and the denominator will cancel. And so that's going to eliminate that discontinuity at x equals 1, and that's going to leave me with the limit as x approaches 1 of 1 over x minus 2. Now I can do direct substitution. When I do direct substitution, I can take the limit off. I don't write the limit any longer. And we get negative 1. Now let's look at another problem here. So I have another rational function, and I start off by doing direct substitution. So I put in 2 for all the x's, and I get 0 in my numerator and 0 in my denominator. That is the indeterminate form. And so I need to perform some kind of rewrite here to see if I can't simplify the problem. Well, the issue that we have is we can't necessarily factor the x to the 5th minus 32. I have to use a different technique. And so what I'm going to do is I'm going to use synthetic division to try to rewrite the 2, put the 2 in the box, if you forgot how to do synthetic division. And then I write my numerator, all of the coefficients. So I have 1x to the 5th, 0x to the 4th, 0x to the 3rd, 0x to the 2nd power, 0x, and then negative 32. Leave myself some room. I drop the first number down, and then I multiply it to the number that's in the box, and then I add. And then I repeat. Multiply to the number of the box, and then add. Multiply to the number of the box, then add. Multiply to the number of the box, then add. Multiply to the number in the box, and then add. And the last number should be 0. And now we can rewrite our limit. So basically what we did was we showed that x to the 5th minus 32 could be rewritten as the product of x minus 2 times x to the 4th plus 2x to the 3rd plus 4x squared plus 8x plus 16. And we can cancel out the x minus 2's. And now we have the limit as x approaches 2 of this polynomial. And now we're ready to do direct substitution. And we get 80. All right, let's look at another technique here. So I'm looking at this limit, and I always start, I put in what x is approaching to see what happens, and I get 0 over 0. I get that indeterminate form. Now, when I see a limit and I have an indeterminate form for direct substitution, and I see a square root, and especially a square root plus or minus a number in either the numerator or the denominator, the technique is we're going to rationalize this problem by multiplying by the conjugate of that irrational part. So the conjugate of my denominator is going to be the square root of x. I'm going to just change the sign, so from minus to plus, square root of x plus 1, and I'm going to do that to both the numerator and the denominator. And once I do this, I'm going to multiply, but I'm going to strategically multiply, because what I want to have happen is I'm hoping to get the x minus 1 to cancel out with something, so I'm not going to FOIL out the numerator. But I am going to multiply out the denominator. So the square root of x, we have a difference of squares, so that's going to leave me with x and then minus 1. So difference of squares when I multiply the denominator. Now we can cancel out the x minus 1's. I'm going to rewrite the limit here. So the limit as x approaches 1 of the square root of x plus 1. Now we can do direct substitution, since we removed a discontinuity or simplified our problem, and that's going to give us 2. All right, let's look at another algebra technique here, and that's when we're working with a complex fraction. And when we put in negative 1 everywhere, we get negative 1 over undefined minus 1. And so this isn't necessarily an indeterminate form, like 0 over 0, but I have, I need to rewrite this problem so that way I can see what its value is. So what we're going to do is, anytime I'm working with the limit, I have to rewrite it. Is I'm going to multiply to get rid of the fraction, the denominator, and if I pick to multiply by 1 plus x, that'll remove that fraction, and I'm going to do it to both the numerator and the denominator. And so let's see, my new denominator becomes 1 minus 1 plus x, and then I can simplify that denominator a little bit. And that takes us right here. Now, notice nothing necessarily cancels out. Well, that's not the end of the world, because once I do this rewrite, I can now put negative 1 in. I can see what I get. And I put negative 1 in, I get 0 over 2, and that's just 0. So with the complex fractions, even though we might not end up with a 0 over 0 indeterminate form, we often need to rearrange this problem so that way we can perform direct substitution and successfully get an answer.